And before I start, I'd like to thank everyone at the ABYC, John included, as well as Wendy Larimer and everyone at AMI for including me in this presentation. Just to give you a brief rundown of what we'll be discussing today. First, we'll go over what exactly is an electric shock drowning. I know many of you were on the call with Kevin Ritz a couple of weeks ago, but I'd like to address some of the basics of what an electric shock drowning is, some of the causes of these incidents. We'll also address the NEC 555.3, which is a new code for the 2011 NEC version that addresses what sort of protection needs to be present in any new installations and where that protection can be located. Also, we'll take a look at what can be done to lessen the chances of electric shock drowning, including some general rules that you should use throughout your marina, as well as ways that you can lessen the chances of there being an injury through circuit breakers or ground fault monitoring or a couple of other circumstances. We'll also go over the NFPA 303 section, which discusses what type of maintenance and testing needs to be done in a marina each year to make sure that there aren't characteristics present within the facility that could cause damage to boats or more seriously injury to any of your boaters. John gave a pretty good description of what my bio is. I'm the Senior Applications Engineer for Marina Power and Lighting, overseeing their electrical design portion. Mainly deal with power pedestals and distribution equipment on the marina side, and I have spoken at a number of events similar to this over the years. With that said, we'll get into what electric shock drowning is and the causes. Again, this is going to be a repeat for some of you that were on Kevin's call, but again, for those who haven't yet gone through that, let's just give you a brief rundown of what that is. Electric shock drowning occurs when there's some faulty wiring on a boat or within the marina that causes metals to be energized somewhere within the facility. Typically that's caused by some faulty wiring and a inadequate ground system that causes items such as boat props or dock frames to become electrified. While they become electrified, this leakage of electrical current enters the water and creates a gigantic electrical field, which you could have swimmers or people that simply fall off dock enter in the water. The magnitude and intensity of these fields can be determined by how much leakage is in the water and how close your swimmers are to the cause of these leakages. Basically, a swimmer enters the water of an electrical field and completes a circuit. If you think of an electrical circuit as a large cycle, whatever comes back or whatever goes out of an electrical source is going to come back through some lines that we'll show you in a little while, and anything that's not brought back in that cycle is going to be returned to ground. And we'll show you how a certain system or an adequate system will be working compared to a faulty system here in a little while. It's much more prevalent in freshwater environments simply because freshwater is close to 70 times more resistant than saltwater. I saw a question a little bit earlier asking to address the differences between freshwater, saltwater, and brackish water. Simply put, the less salt you have in a location, the more dangerous currents can be within your facility, and that's simply because of how the electricity is going to cycle through the water. Depending on the amount of current in the water and a swimmer's location relative to the source, a person can experience a variety of different effects, whether that be a slight tingle to the loss of muscle control to basically ventricular fibrillation. In this case here, if we're taking a look at the little map, relative to, missed a slide there, relative to the location of this boat which is causing leakage into the water, if a swimmer is within that small purple circle, they're likely to see close to 50 milliamps of leakage. Again, this is just an example based on a chart we'll take a look at here in a second. And as you get further away from that power source, the amount of leakage that a swimmer will counter becomes a little less. showed something similar to this with his presentation a couple of weeks ago, but this just shows the effects that people can see. 1 milliamp to 8 milliamps, there may be a slight tingle or shock. That's often one of the things that we really concentrate on when people ask us what are some signs of a potential problem within the marina. As you get a little more amperage leakage, you could see a painful shock or muscle control loss. Muscle control loss, in my mind, is really the big issue. That's when you have complete loss of control of being able to swim and get away from the dangers that are in the water. As you get to the higher amperage leakages, that's when you get into pretty much automatic loss of control, automatic death. To give you an idea, the current, the amperage that is leaked into the water is the big issue. It's not a voltage issue, it's the amount of current that's in the water. And as an example, a typical light bulb that you would use in your house uses about 100 milliamps. If you take a look back to the left on the chart, that 100 milliamp level right here is that's pretty serious damage there. So that's one of the things that we'll take a look at here in a few minutes. Typical electrical circuit, you're going to have a power source similar to a circuit breaker that's going to send electricity through the system, through a circuit breaker. Again, think of the electrical system as a huge cycle. The black and red lines are your two hot lines, your hot leads. They are current-carrying conductors. They're going to send electricity through the circuit breaker into the receptacle. The white line here in the middle is control, which is actually going to return the power back to its source to complete the electrical circuit. And this green line here on the bottom is what is catching any current that is not completed through that neutral package. So anything going out, it's kind of a simple way to look at it, but what goes out should come back, and what doesn't come back should be picked up by the green wire or the grounding wire if everything is working properly. Again, I don't know how well you can see that cycle through what we just looked at, but this is just a zoomed-in picture of what you were looking at, where the black and red wires are sending the electricity through the receptacle, and the returns are going back on the white neutral and the green ground. And a perfectly healthy or perfectly adequate electrical circuit, again, just as a kind of a blown-up example, we're going to have 30 amps of power going out. Our neutral here picks up 29.5 amps, and the ground wire picks up the remaining half of an amp. That means that we're not having any leakage into the water here. That is what a properly working grounding system and electrical system will look like. In a faulty system, using the exact same example, we're going to have 30 amps going out, and let's say the neutral line only picks up 29 amps. The ground may have some sort of issue in it here where it's cut, it's pinched, could be loose connections, could be a variety of things that are causing that neutral to be inadequate, but that results in half of an amp here entering the water. And that half of an amp is what causes problems such as swimmers being injured, props being damaged, certain things like that. As a brief summary, there are two that are required for an electrical shock drowning. There needs to be an electrical fault to ground, either caused in the marina or on an inadequately wired boat. And there also needs to be an incomplete circuit caused by faulty or non-existing circuits back to the grounding system. There needs to be some sort of an issue or some sort of problem with the grounding system allowing that leakage current to enter the water and potentially become a serious problem. With that said, we'll get into the new NEC Code 555.3 requiring ground fault protection on all new installations. Again, this is new to the 2000 Electrical Code. I'll read this verbatim. The main overcurrent protective device that feeds the marina shall have ground fault protection not exceeding 100 milliamps. Ground protection of each circuit breaker or feeder circuit shall be permitted as a suitable alternative. Now, to give you a definition of what an overcurrent protection device is basically the kill switch or the kill mechanism if there are any issues within the electrical circuit that will cut off power to that circuit. Circuit breakers and fuses are common examples of these overcurrent protective devices. Circuit breakers are by far the most common form using the ground fault protection. Somewhere within your electrical system, this new code requires you to have 100 milliamps of protection, meaning that anything that exceeds that 100 milliamps is going to turn off everything that is attached to that electrical protective device. Those of you that have ship stores and other floating buildings, there's also a similar code that applies to those residences or those buildings, also requiring 100 milliamp protection. It basically reads the exact same way as what's written above. It's just listed in a different section that you can find in 553.4. Now we'll get into where you can actually locate this ground fault protection. There are a lot of different locations you can place it, and they all have pros and cons on not only cost, but also being able to detect what boat or boats are causing the leakage into the water. We'll start with protection at the utility entrance. You can put an enclosed circuit breaker with GFI protection. There are also a couple of other different methods, but that enclosed circuit breaker is the most popular. Basically, you put this right where the incoming power is entering the facility. It's a very economical solution, depending on the size of the service you're looking to control, because you're only buying one piece of equipment. It's just a circuit breaker going to have the ground fault protection in it. With it being at the head of all of the electrical circuits that filter from your distribution panels down to your boats, it's going to be very difficult to pinpoint the exact cause or causes of the leakage unless you go pretty much boat by boat turning on circuit breakers to figure out what boat or boats are causing that main circuit breaker to trip. Leakage grouping, which we'll go into a little more detail in a couple of slides, will also be a drawback. Leakage grouping basically occurs when there are multiple boats causing leakage into the water. They may be providing small amounts, but if you add all of them together, that's what's causing a circuit breaker to trip or there to be problems within the marina.
Chris, this is Gary. Can I inject something there?
Go right ahead, Gary.
I agree 100% with what you're saying. That's the most economical place to put the GFP. However, it depends on the design of your marina. If you're supplying the marina from the utility with 480 volts because of voltage drops concerns, and then you're stepping voltage down on your marina with transformers, putting the GFP at the main will not detect ground faults on the secondary side of the step-down transformers. So that you need to be very careful in the way where you put that. If you put the GFP at the main, you also will be required to put it on the secondary side of each of the step-down transformers to detect the ground faults on those separately derived systems on your marina.
Certainly. Thank you, Gary. That is definitely a point that needs to be on that slide, that it needs to be something other than a high primary voltage, whether you're being supplied with 600 volts or 480 volt or anything other than that. It needs to be applied on a 120, 240 volt or 120, 208 volt system to operate effectively.
Now, the code language in 555.3 it could be a little bit deceptive because it does say on the main. But depending on your design of the marina, you need to be careful about that.
Certainly. And I don't know if I mentioned it before to the audience. We have Gary Loftus is with us. I've asked him to chime in with anything like that could be construed differently within the code or something that I may not be explaining to the extent it needs to be. So if you hear Gary chime in from time to time, that is more than welcome on such a serious topic. The next place we'll look at protection is at the head of each dock. And again, as Gary pointed out, it needs to be protection where you have it on a lower voltage, be it 12240, 12208. You're basically providing circuit breaker protection at the head of each dock using some sort of a disconnect or distribution panel. Again, this is a relatively economic solution to some others that are out in the market. Identifying the causes of the leakage often depends on how the system is wired, and we'll also go over the differences between identifying the culprits of leakage based on how the system's wired here in a minute. The effects of leakage really depend on the number of boats that are being controlled by one piece of equipment. If you have multiple boats that are supplying small amounts of leakage into the water, you have an instance where you're getting the circuit breaker trip quite a bit, even when some of the boats are not producing a leakage that's high enough to make a circuit breaker trip on their own. Collectively, they are producing enough leakage into the system to cause a circuit breaker to trip or a system to shut down. You can also provide protection on the dock, whether it be through distribution panels or substations, transformer panel board combinations out on the dock. You can provide the protection in those locations as well. You can also provide it through ground fault monitoring with shunt trip circuit breakers. There are some small monitors, which we'll show examples of toward the end of the presentation, that are adjustable and can pick up certain leakage currents and can be supplied with pieces of equipment to turn circuit breakers off. It's a little more economical than just providing GFI circuit breakers throughout the system, and it does meet the intent of that 555.3 code. It's a little bit more costly solution, but it makes it relatively easy to identify the cause or causes of the leakage. Depending on the number of circuit breakers you have controlling a certain number of boats, it may be to the point where you track down the circuit that's causing the leakage or causing the alarm to go off, and boat by boat turn the power back on these vessels, and whichever vessel is causing the alarm to trip or causes the reading to spike, you know that you've identified a cause or causes of the current entering the water. Again, the effects of current leakage on this system will also depend on the number of boats being powered by that piece of equipment. So knowing the number of units that you have on a given circuit or on a given detection device is important to understand how to identify the units that are causing the problems. You can also provide protection in each power pedestal through GFI circuit breakers on each unit. This is a little bit of a tricky installation or monitoring device because the GFI circuit breakers are much more expensive than a standard circuit breaker, but you will be able to identify the culprit of the leakage into the system very easily with this solution. If a circuit breaker trips on a piece of equipment and in good working condition, you know that that's the boat that's causing the leakage or the piece of equipment that's causing the leakage into the water. Again, it's a very costly solution, but much easier to identify who's causing the problems within the marina. Also, leakage grouping is not an issue with this solution, as each circuit breaker is individually monitored. So if you've got an issue with an alarm or you've got an issue with a breaker tripping that's GFI protected, you know that boat or that piece of equipment is what's causing the damage.
Chris, this is Gary again. Can you explain, or maybe this is something for AYBC, if a vessel or a boat has the neutral and grounds bonded together within their system, the ground fault monitoring, will it alarm at that state because there will be a parallel path for neutral currents and it will be an imbalance between the neutral and the hot leg?
That's not an instance that I'm fully aware of. Kevin or Chuck Devitt, Captain David Rifkin, those guys are probably more suited to field that question than I would be.
Okay.
I can tell you, Gary, that the standard is that neutral and ground are not tied together on board the boat, except if it's the secondary of an isolation transformer or if you're using a generator or an inverter where you would not be hooked to shore power.
Right. I understand that. I have spec'd and designed systems with ground fault monitoring, and when there's several boats that have plugged in and they have neutrals and grounds connected, and it will alarm in that state. So those vessels need to be wired so that the isolation between grounds and neutrals are present. That is one issue with especially existing boats and marinas.
Thank you, Gary. Just want to give an idea of what we meant by leakage grouping a little while ago. There are probably tons of different terms that are used to describe this, but basically it's the collective result of multiple boats that could be producing stray current into the water. Basically we're going to get multiple vessels that are putting small amounts of current onto a system, either protected by a piece of ground fault protection or a monitoring device. Leakage produced by a single vessel may not be high enough to trigger a circuit breaker, but the collective leakage by multiple boats may cause something similar to a 30 milliamp circuit breaker or a 100 milliamp alarm to go off, depending on the amount of leakage being put into the water. Again, it's much more prevalent on systems where there are a large number of boats. If you think about it as a crowd at a sporting event, if you have a large crowd, say 200, 300 people yelling, they're obviously going to make much more noise than only a couple of spectators. So it's kind of an example that we like to use, where 100 boats are going to produce a lot more leakage than a couple in most cases. As an example of leakage grouping, the boat on the right may be producing a few milliamps of leakage, and the boat on the left may be producing a few. So collectively, you add those together, coming off of that same protective device, and they may be enough to trip a circuit breaker. As another example here, we've got boat A producing 4 milliamps, boat B producing 5, and boat C producing 6. As a grand total, those boats are producing 15 milliamps. And if we go back to our chart on what a swimmer would see, 15 milliamps is enough to produce pretty damaging results, enough to produce loss of muscle control and the inability to swim, which could lead to a unintentional drowning. So that's something to keep in mind when you're taking a look at what system you choose for protection or monitoring. We also discussed the differences on how wiring methods will affect the way you monitor, or how difficult or easy it would be to identify what boats are causing problems. The first we're going to take a look at is the loop feed wiring system, also called daisy chaining. Typically you're going to see multiple pedestals looped together on a single circuit. They're all protected by a single circuit breaker or fuse back at the power source. And in this case, we're going to find that, again, the more vessels you have on a piece of equipment, the more likely they are to produce a collective leakage into the water, which could be potentially harmful. The leakage group effect, you're going to have more devices powered by a single circuit breaker, and therefore you're going to have a higher likelihood of current leakage into the water being high enough to alarm or trip a circuit breaker. On a loop feed system, also because of the number of boats you're going to have connected to that system, it can be difficult to pinpoint the cause of the leakage or cause of the alarm tripping or alarm signaling based on trying to figure out, if you have 16 boats on a single circuit, trying to identify which one or which couple of those boats are being the most problematic within the system and causing that leakage into the water. The next system is what's called a home run method. Typically means that you have one circuit breaker for one pedestal or one circuit breaker for every 2 boats. Very common in areas that require onshore, but also it's a personal preference. I know we do some work with electricians that like to have all of their power pedestals on one circuit breaker, simply because if there is an issue with a breaker or with a boat, you're going to have only a couple of boaters without power if there needs to be any kind of repair work done. The applies with the monitoring system. If you've got one boat that's particularly causing a problem, it's much easier to identify on this home run system where you only have to worry about one or two boats being powered off of a single protective device. Number of vessels on this system very low, as each boat is getting, you're going to have one or two boats again on an individual circuit. The leakage grouping effect is also low because again you're going to have only one or two vessels being powered by that circuit breaker. Also very easy to detect the cause or causes of the leakage, as you're only looking at one or two boats if you do have an issue with an alarm or with the circuit breaker tripping. Now we'll take a look at what can be done to lessen the chances of an electrical shock drowning. Some of these will be pieces of equipment, some of these will be just standard rules that you should follow throughout the marina. But based on presentations by a handful of people, Kevin Ritz, John McDevitt, Captain David Rifkin,
Yeah.
Jim Schaefer, David Pasco, just to name a few.
Hi. Okay. Yeah, well, that's what that's the main thing, because that roof dumps a lot of water that's washing out everything every time it rains, you know. Okay, that's with, what, 2 downspouts, or what do you? Okay, and then, so that would be one on each corner, basically? Then how do you, you got a shadow board up there? How do you? Okay, and that's enough support. How did it was so it'd be hanging down over the below the shadow board. Okay. So how much does that thing tip? I mean, do you have to? Uh, okay, so you just kind of start in the middle and tip it towards the edges, then, eh? Okay, what is this? Is this aluminum or what is it? Okay, and what color is it? Okay, like pretty much like those Anderson windows, that color, or darker? Okay, all right. So we got 5.5 for the back. I'm just curious on the front. Are you on the front of the house by any chance right now? You see that, along the porch area there between the two dormers, kind of? What would you do there? Would that be a single downspout or double? Or how would you do that? Uh-huh. Okay. All right. Well, I may have you back and do that possibly if that turns into a problem. But the back, is that something you could do right away? Okay. All right. I think we're going to get a bunch of rain here end of the week. Um, so I guess giving you enough notice on this thing. Well, let's go ahead and order it anyway, and maybe I'll hold off the excavator for a week or something. Because I'm afraid that back end, if they get it done, it might get washed out. Well, I'll leave it up to them, I guess, you know. And then, what do we do with all this rain then coming down these downspouts? Is that just, that's up to me to figure out how the hell to handle it? Okay. Mm-hmm. It's pretty tough because it's going to run off into the next lot is what's the problem is, right? So I'm just trying to think of how to diffuse it, you know. Uh-huh. Yeah. Okay. At the end of it or something? And that kind of, so if it's too much for it, it just relieves, right? Okay. How big is this gutter? What? 5 inch? Okay. All right. Well, let's go ahead and get it ordered and plan on doing it as soon as you can do it. All right. No, I can. I've actually got on the front corner there. I've actually got that in place already. You know, the gravel that goes along. I mean, the front, not the side. The Yeah, that's actually. I've got piping and stone buried under there that goes all the way to the property line, or into that evergreen tree, basically. And kind of, so I could dump it. I could dump into there. It's the one up on top I'm not sure what to do with. So I'll play with that. Maybe I'll just when they excavate, maybe I'll just have them put a bunch of stone in the ground and basically do what you're talking about. Yeah. Right. Yeah, because I don't know I don't know what to do with it. That's why. You know, it's that's taking the water off that side and also out of the garage floor, and it's not. I'm just not sure what to do with it yet. So I'll figure that out myself. So if you can go ahead and get the gutter itself up and downspouts, that'll make it good. Okay, thanks a lot. Bye now.
Have 100 protection on any new installation. And also, you'll see that 100 milliamp protection, but if you look one slide down or one location down, you'll see that 15 milliamps is enough to cause potential problems. The code was put in as kind of a stepping stone to let everyone know that this is a serious issue, but with a little more research and development, we think we can get down to what not only is an economical solution, but also a safe solution for owners, operators, and manufacturers. This is an example of a typical customer renovation that we see. This person has basically tied their both side electrical cord right into a bus bar system on a power pedestal. Likely caused by somebody running over the unit, but still this is potentially dangerous on a ton of different levels. Not only is there no circuit breaker protection present anywhere on this unit, the bus bar system that I'm going to circle right here, those are live connections. Anyone that comes by, whether it be inadvertently or whether they're just curious about why there's a buzzing sound, if they touch that's a real potential for a problem. Serious shock could cause death. It could lead to a lot of different things. So we'll talk about some of the inspection stuff that you should do on a regular basis, not only because it's required, but because it's very easy to do when you walk through your facility. If you ever see anything like this, the power to this sort of thing needs to be turned off, and you need to find out who did it. And they need to be educated upon why this is not acceptable within your facility. Another form ground fault monitoring systems. You can install a ground fault monitoring system pretty much anywhere in the marina. It can be done on new installations and also most existing installations. It usually consists of a control model that can be adjusted to certain leakage levels, and we'll show you what the current transformers and how they work here in a minute. But basically, you've got wires that are running through these donut-like objects that are measuring the electrical cycle that's present within a circuit. A couple of different models. You're going to see single source monitoring where you can monitor one major power source. And you can also find multiple source monitoring where you can identify individual circuits that are causing issues within the facility. The monitors are going to come in a variety of different shapes and sizes. This model by Bender, in my experience, very easy to adjust. You can set it right at the 100 milliamp level, or if you're concerned with more leakage, or if you want to set it at that 15 milliamp level that could cause painful shock and muscle loss, you can certainly do that from this same device. It has a wide range of uses. You'll also see some ground fault monitors that have integral CTs where you're running your wires directly through the hole here at the bottom. Also a pretty easy to use and innovative solution. This is an example of a single source monitoring device. Basically, we've got the main circuit breaker up top here, and this limit device will run our wires through that. It will transmit that information back to our ground fault monitor here. So as it sees the cycle of what's going on, comes back to the ground fault monitor, and the monitors typically have some sort of visual devices, whether it be green means the unit's on, yellow means that there is a minor problem, or there's enough of a caution level, not high enough to trip a circuit breaker or to cause a full-blown alarm. That's some stuff that's out on the market right now, and typically you'll see that there's an alarm or a strobe light that can be activated if you have a potentially hazardous, potentially dangerous leakage into the current or into the water. From a cost standpoint, the single source monitoring device is relatively inexpensive. You're providing a single CT around usually the main circuit breaker or main lines coming into a piece of equipment. Leakage grouping can be a cause of concern for this device because you're going to have as many boats or vessels being powered by that single circuit breaker or powered off of that piece of equipment being judged as a collective group rather than on an individual level. That also makes pinpointing the cause or causes of the leakage very difficult because again, you're going to have a good number of vessels being monitored by that one device. Next thing we'll look at is a multiple force monitoring device. With this sort of system, you're going to have a single CT, single current transformer being provided for each circuit breaker. So this circuit breaker has its own down the line. These devices are also going to send their information back to the monitoring device, and depending on the system you have in place, that monitoring device can send out a small signal turning off your circuit breakers. So whether you want to see a visual alarm or whether you want to have the power for that monitor to go ahead and turn off the circuit breaker that's causing the issue, you can set the system up either way. From a cost standpoint, compared to the single source monitoring, the cost is higher. Multiple CTs can be expensive due to the number of CTs that are required. So basically, for each circuit breaker, you're going to have its own CT. When you get into larger panel boards that may have up to 20 circuit breakers in them, that's 20 more pieces of equipment you're going to need to buy. From a leakage grouping standpoint, this is a very, very low effect. Each circuit breaker is going to have its own monitor, and it also makes detecting the cause or causes of the leakage a little more easy to locate, because if a circuit breaker is tripped or if alarm is triggered, it's going to give you the exact location of where that issue is coming from, whether it be one or two boats or whether it be an individual circuit breaker. It's much easier to track that down through the multiple source monitoring devices. Some first aid for shock victims. This was some stuff that we found off the internet. Basically, the most important thing to know is that if you do have an area where you're noticing tingling in the water, or if you notice someone come in contact with some electrical current, the most important thing is to make sure that all power sources are turned off immediately. No one should enter the water until that area has been deemed safe first. I know that's a very difficult thing to do, especially if you see someone who's in distress in the water. It's in most human nature to jump in right after them, but if it is an electrical shock drowning, it's extremely dangerous for multiple people to go in. Extreme caution should also be taken when removing the victim from the water, just in case it is some sort of spinal injury and not anything that could be listed as a electrical shock victim. 911 should be called immediately, and once the victim's removed from the water, if the victim has a pulse but is not breathing, artificial ventilation should be started right away. CPR should be performed on victims without a pulse and without breathing, and if you have an AED on hand, an artificial electrical defibrillator, that should be used on any victims without a pulse and who are not breathing. Signs of electrical shock drowning or potential problems. Electrical shock drowning often leaves no bodily clues. It's listed as a simple drowning because there are very few signs that show what's happened to the victim. There are oftentimes no burning signs. The victim is usually submerged in the water due to muscle loss, so there are no signs of electrocution. Signs of a potential problem: if you hear anyone complain of tingling while being in the water, that's something that needs to be that electrical system needs to be shut down immediately. That's one of the first signs of a serious issue. Whether the person hasn't come close enough to the source to really experience the full potential of that shock, or whether it's the boat owner or a piece of equipment may have some characteristics of it that aren't working at the time to where they're not putting their full level of electricity or electrical current leakage into the water. Anyone complaining of tingling, that needs to be investigated right away. Also, if you have excessive damage of boat parts in the water, props, anything like that, that's also a sign of electrical leakage, which could be a very big problem. We'll go over some maintenance of the electrical wiring and equipment. Again, this is required by the National Fire Protection Organization 303-5.20. Again, we'll read this verbatim. An inspection of all electrical wiring, ground connections, conduit, hangers, supports, connections, outlets, appliances, devices, and portable cables installed or used in a marina, boat yard, boat basin, or similar establishment shall be made at regular intervals to ensure a complete inspection at least annually. Basically, this is required for any marina owner or operator to do this at least once a year. The big portion of this code requires that the ground integrity or polarity of your grounding system, that needs to be checked as well. That's the big issue. The ground is probably the most important piece of equipment you're going to have in your system, and making sure that that's working properly is very important. The bottom statement there, if you find any grounding type of portable electrical equipment that is not working properly and adequately grounded, it needs to be removed or repaired immediately. Some things you're looking for, and this is not something that needs to be done by a certified electrician on a monthly basis. This is something you can take a look for when you're going out, talking to your boaters, talking to people within the marina. If you see any signs of melting or burning, that's a sign of a potential problem. Could be related to the grounding system, could not be related to the grounding system, but more importantly, it's a sign of a potential fire. So that's something you can take a look for when you're on your daily inspections or daily walkthroughs that you or your dock hands may be doing. Any sign of burning, arcing, melting, fire, smoke, anything like that, also a sign of a potential problem. Any exposed cables, whether it be from movement of the docks, scraping, boats running into it, anything where you have exposed conductors. On this picture here, you can see there's some exposed copper on these cables, probably due to dock movement or some other source. But anything like this, especially if you see it on a green wire, that's your ground wire. That's a sign of a really big problem. Again, exposed cables, anything like this where you could see oxidating, rusting of the internal metal conductors, that's the sign of potential fire hazard, potential problem. Similar picture here where this looks like the wires have been run between those gas lines or sewer lines there in the middle. That needs to be replaced right away. Again, you've got some cabling here where the jacket appears to be starting to wear off. Once those conductors are exposed, that needs to be taken care of right away. Any sort of open conduits where you've got connection points that are open, this is where you can have water seep in, cause damage to your wires. That's another sign of something that needs to be taken care of. Against those conductors, these should either be capped off, cut off, or removed, or simply removed, just in case a circuit breaker is activated without the knowledge of someone out of the marina. If someone walked up to this and touched it, that could lead to a very serious issue. Any sort of exposed wiring, these appear to have been capped off or turned off a while ago, but any sort of exposed wiring, anything like that, should be covered up in any way that you can. Missing parts and component pieces, having an exposed door like this can lead to damage to the receptacle. Looking for circuit breakers that are exposed, things like that, that's something that can be taken care of very easily by contacting your equipment manufacturer. I'm not really sure what this is. There are so many things wrong with this picture, I don't really know where to begin, but the installation itself appears to have some issues with it. There's also damage to the receptacle. GFI receptacles built like this should not operate if they've been damaged, but it's something that needs to be taken a look at when you're doing your walkthroughs. And this is one of the more scary photos that I've seen in a while. I don't know how well you can see it on your computer screens, but a customer has actually opened the circuit breaker on this circuit because I'm sure that there's some issues with the boat or whatever that's powering, and the circuit breaker continued to trip, so the customer decided to tape it open. Depending on the manufacturer of the circuit breaker and the age of the circuit breaker, it may not do that customer any good, but it's not something that you want to see where someone tapes open a circuit breaker in the on position to where it could potentially lead to a very serious problem. That's all I have. My contact information is there. If anyone has any questions about anything, I know John had a couple of slides to go, and also we were going to do a roundtable. Again, I want to thank everyone for being on the call today, and really appreciate being included. Thank you.
All right, thank you, Chris. Appreciate that. While Chris and Gary get set up for our Q&A, I'd like to mention a couple of things going on here at AUIC. First and foremost, our new standards have been released. Included in the 2012-2013 release is our new EN11, AC and DC electrical systems on board boats, and 15 other standards. Specific to this webinar and the last one that we presented, our ELCI requirement is in that document, and we are looking at December 31st, 2012, unless an isolation transformer is installed on board the boat within 10 feet and properly supported, you need an ELCI after December 2013. Also, coming up in the next month or so, we will have available for purchase, we expect a low-cost way to determine whether a boat is emitting any leakage current onto the dock. If you take a look at the picture that we have on the screen there, this is simply right now 30 amp pigtail with the same technology that is used in the boat ELCI. The idea is plugging in every boat every year and making sure that all the boats that are at your marina are not leaking any current into the water. And this is we had one question on the chat room, and this is a very easy way to determine it. There's a light as well as a buzzer. This particular model that you see on the screen does have the ELCI breaker in it, so it will cut off the power. We're also looking at one that just has a visual or a audible indication so that you can do some fundamental troubleshooting to try to figure out what circuit on board the boat is having an issue. So that's something that ABYC is working on now. And with that, I'm going to go ahead and start fielding some questions. Chris and Gary, I do have a load on the list here, so I'm going to go ahead and start with a couple. This one was interesting. It was about grounding conductors and how they're handled on board the dock. And the question is, what does the NEC state regarding the installation of grounding conductors on the dock? Is daisy chaining the grounding conductor acceptable? And this question, the guy that answered or asked the question said that he believes that daisy chaining the grounding conductor on the dock exposes multiple slips to the possibility of allowing straight current in the water. So would either of you like to comment on that?
The code does allow for daisy chaining of the grounding circuit. Typically, it's going to go back to a single source, whether that be an enclosed circuit breaker or a panel ground, and then that ground is run to shore in most locations. But it does allow for that ground to be looped together.
Okay. Moving on a little bit, I have a comment that just came in. It says that their electrician for the marina states that a 30 amp shore power breaker is designed to trip at 24 amps. Is this true, and are the circuit breakers designed this way?
Most standard circuit breakers are going to be designed to trip at 80% of whatever they're listed at. So your electrician in that case is correct. A 30 amp circuit breaker is to trip at 24 amps. That 24 amps does need to be seen for a certain period of time. What this is called is kind of motor startup current. So if you have something that turns on that spikes the amperage over 24 amps for a brief millisecond, it's not going to trip the circuit breaker because the motor eventually is going to come back down under that 24 amp level and allow that circuit breaker to operate under normal conditions.
Okay. This next question was based on slide 11, which was your basic electrical design, Chris, and it said, why would you expect 0.5 amps on green wire in a perfect electrical circuit? Someone would expect that 0 amps on the green wire unless there's a fault on board the boat.
Ideally, you're correct. In that example, we're trying to show that a proper working grounding system should pick up any stray current. So is that an exact definition of a perfect system? No. But it is the definition of a perfectly working grounding system. So that can be a little misleading.
I have another question. I think we addressed this pretty adequately, but I think it's worth going over again. And this question is from a marina owner that's located on an inland freshwater lake, and they do restrict swimming around the docks, but they don't absolutely prohibit it. What if they have GSCI equipment on the entire marina? Would they then be allowed to let swimmers in the water? And they do have maintenance divers in the water, obviously. Should they shut the power off? And I think it's worth talking again about those the power-free days or time periods that you were talking about, Chris.
The power-free time period, I had never seen that used until I went to a marina up in the Northeast not too long ago. It's a pretty novel idea because if you do have the in-water electricians, the in-water divers going throughout the marina, whether it be to do exterior maintenance or simply just do bottom cleaning, it's important that they know the dangers of being in there if you don't have fault protection. One thing that can be a little misleading, depending on the type of ground fault protection you have within the facility, it's going to depend on the level of which you're protecting people. If items are listed at 5 milliamps, which again is people protection, the chances of you having an incident within the facility are obviously less likely than if you have, say, a higher milliamp protection. Ideally, you'd like to have people come into the facility and let them know that there are going to be some dangers. Another thing that I've seen, which we don't really go into in the presentation, is that they have, I guess, kind of working windows within the marina, not time frame windows, but areas kind of away from the docks and away from electrical equipment that can be used for your in-water divers or people that want to do some kind of housekeeping on their boats, on the exterior of the boats.
Another question. The city has a swimming beach about 300 feet directly landward of our closest dock. Is this too close?
That's a tough question to answer because you're not sure of the leakage that's being put into the water. A lot of it would also depend on the type of water that this person's in. If it were a freshwater marina, if it were a place with a lot of older boats that with people that may not have kept up with the maintenance or have had the work done by certified electricians, that in my mind is pretty close. Especially if you have somebody maybe swimming over to greet somebody on a boat, something like that. That's we've had that happen with at least one fatality that I've known of. So in my mind, that's close. But again, it's going to depend on the circumstances that are present.
Gary, in the work that you've done, have you seen a land-based installation being affected by a neighboring marina?
I have not. Generally, current wants to go back to its source. So if a swimming area that's significantly away, which I agree with Chris, 300 feet may not be enough, but generally the current's going to go back to its source, which is the shore power, and generally it's going to go back to the grounding system if there's a leak in the water. And the marina, if it's made of metal on the marina, and if the boat holes, adjacent boat holes are grounded properly, that current leakage is going to go back to the marina itself. But there is the chance that a close swimming area could be affected.
Okay. This is a question about the ground fault monitors that you spoke of earlier, and the question is, do they meet the new requirements for the 100 milliamp protection under the current NEC? So do you need to have the 100 milliamp protection as well as the ground fault monitor, or could you have a ground fault monitor on its own to negate the need for the 100 milliamp protection?
We've found with most inspectors, if you run that by them prior to the installation being completed, and this is one of the big things about planning and keeping those guys involved, it meets the intent of the code. If you have the ground fault monitor and you set it at the 100 milliamp level, and you also tie that ground fault monitor in with what's called a shunt trip device that's going to turn that circuit breaker off if the level you set the monitor at is exceeded. So as long as the monitor is set at 100 milliamps and it's protecting at that level, which is listed in the 555 portion of the electrical code, we haven't had anybody turn us down with that as being sufficient. But again, the authority having jurisdiction, the electrical inspector, his word or her word is the law in any location. So it's something that I would definitely run by that person prior to doing that installation.
Gary, in the designs that you're doing right now, are you speccing out a ground fault monitor?
I have done both. I've done ground fault monitoring, and also I have a project with the state of Tennessee where we will be implementing the 555.3 100 milliamp requirement as well. Even though Tennessee has not adopted the 2011, I think about 21 states have adopted 2011. So there's quite a few states that are still under 08 or 05. To answer your question is, I've done both, and me being a deputy electrical inspector myself, I would accept the ground fault monitoring with a shunt trip breaker, because mainly there's very little options out there, especially if you want to put the ground fault monitoring or the ground fault protection on the main.
Hello.
I know that Square D, the largest ground fault
Hi, Steve. How you
protector
doing?
on a branch circuit like that, will go down to 100 milliamps with about 250
Oh, hallelujah.
So if you try to run a marina off of 250 amps, you're in trouble. So if you're wanting to do it just once,
Okay, if I can get that tracking number as soon as I can, so I can forward it on to Hallmark, they're probably about fit to be tied right now, you know? Okay. Okay. Did they give any idea, what are we, about 3 or 4 days away then? So they could show up this week then. Monday, yeah, okay. All right, good deal. Yeah, all right, Steve, thanks. Bye.
Planning stage and have to go back and rip up stuff that you've already purchased or installed. So that's we've never had it turned down when it's been brought to the authority having jurisdiction attention in the planning stage, but we have had it rejected after the fact.
Okay, those are both excellent points, and it's a good segue into another question that we have asked about regulation and other laws regarding electrical safety in marinas. And the question is, are there any states that currently have a specific marina regulation? There was one in Kentucky that was offered up but did not pass during their legislative time frame. So what is your experience about any of that regulation, and do you have an opinion about whether future regulation would help or not in water shock drowning situations?
You want to start?
Regulation in Kentucky, and do know that it under the legislation voting. In my opinion, it was pretty strict. They had a lot there that they was trying to get passed, and if there's anyone that is interested in pursuing that, they need to really think hard, because there's some people that have objection to the authorities telling them what they have to do on the marina, even though they're trying to do the best for the safety of the public. Now there's that particular legislation wanted yearly inspections, which Chris mentioned something about the 303, NFPA 303, requiring inspections of marinas, but not all states and jurisdictions are under that code. They have not adopted that. And in particularly, in Tennessee where I live, we are not under 303. Kentucky is under 303. So I think Kentucky, under that circumstance, could enforce inspection marinas under the codes that they are. So if states are under the 303, and marina owners, they need to understand if they are or not, if they're required to have that inspection in their area.
Chris, any comment on that?
From what I've seen, it's really depending on the state, but the incidents over the last few months have really brought that to the forefront, and I wasn't as involved with the Kentucky regulations as Gary probably was, or as up on what the actual codes were going to be, but I had heard it was quite stringent, and that was one of the reasons that there was such an opposition to it. And that's going to be one of the tough things to get this moving in the right direction, is to try to find a balance between what is going to keep people safe and what's going to be affordable for everyone. Obviously, safety is going to be the most important, but if people can't afford it, that's a detriment to our industry that it's not going to do us any good.
Okay. Yeah, and that is always the tipping point there. It's regulation versus expense. You can put a regulation in place, but unless the personnel are available to check it, and unless the equipment is available to meet the regulation, you always end up with an issue, and that's one of the problems that we had with our ELCI when we implemented it on the boat side. I'm going to parry this question because about 4 people asked the same thing in one shot. and I believe it relates more to divers that may be in there to work or to do a recovery operation or what have you. Is there any equipment available that you can check for stray current in the water before you go into a location to do what you need to do in the water?
I know of some probes that you can use, electrical probes that will go into water. Whether they're going to accurately track leakage into the system, I'm not an expert on that. I do know that people have put the probes down into the water to test, especially when they get complaints about props being torn up or losing zincs, things like that. They'll use that to try to identify the cause of it, but I'm not 100% sure if you're going to get an accurate reading that would be safe for the divers to go to the water.
I agree with Chris. De-energization of or turn the power off of the marina is the only true protection. You really, even if you had a device to be able to measure for leakage currents, and then you measure and you find none, then you go into the water, those leakage currents could happen at any time. So you're really not safe with the marina being energized and being in the water at the same time. So the proper method is to de-energize the marina, and then you can enter the water safely.
Okay, the next question, we have two or more and then we'll wind it down, but this is a discussion on 200 amp household breakers supplying dock sections, and at their typical home appliance or Home Depot type store, they can't find a GFCI version in that amperage. Can you offer any solution to that?
They do exist. They are going to be difficult for you to find at a typical hardware store. If you go to electrical supply houses, and for the life of me, I deal with them every day, but I'm trying to think of a name of one that's just not coming to me. But if you look up electrical supply house in the yellow pages or on the internet, those guys should be able to find a higher amperage GFI circuit breaker for you. They exist up to probably 5,000 amps, and they start at as low as probably 5 amps. So there's a wide range. They are extremely expensive, but they're probably the easiest way to make sure that you're being protected, especially if you're using a residence as an example, or maybe a smaller marina.
I think that's an important point about we were focusing on marinas here, but if you own a waterfront piece of property, it's your responsibility also to make sure that these, this doesn't happen. So you're pretty much required to, or you should be thinking about ground fault protection on a waterfront piece of property, whether it's just a convenience outlet or you're hooking up a boat lift or anything. Is that correct?
I would say that'd be the best way to go. It's definitely the safest.
All right. One of our last questions. We have two questions on fires and fire potential, and how can something catch on fire without a breaker tripping. So the first question is, how can you have a fire without the breaker tripping? And if there is leakage into the water, does that increase the potential for an electrical fire, or is it a moot point at that point?
In my mind, it's a moot point. But any sign of fire, any sign of melting, burning, smoke, anything like that is obviously not a good sign to have within the marina. But it's one thing to take a look for. Now, the breaker not tripping while there being a fire or melting, a lot of that's caused by faulty or damaged equipment, whether it be the boat cord or the receptacle. There may not be enough current being drawn by those pieces of equipment to cause the circuit breaker to trip, but the constant either loose connection or melting that's occurring while that piece of equipment's in use is what potentially lead to that fire. It's not from overcurrent or anything like that. It's most of the time seen from just damage over time. You're going to have components melted together, and eventually they'll break, and that's when you'll get the smoke or the fire.
John, the arcing current or arcing faults that occur during a short from a hot leg to ground, those arcing currents can be much less than the overcurrent protection that's ahead of it. For example, if you have a 30-amp receptacle that feeds a boat and there's a short on the boat, it can be arcing, and the arcing currents can be less than that 30 amps and never trip the breaker, but the arc that's occurring in that short can be very, very hot, and if it's next to combustible materials, can cause a fire that way. Also, if you see, which Chris has talked a lot and showed pictures of outlets and plugs that have melted. He mentioned faulty equipment. That faulty means it could be just a loose connection. Also, it can be caused by voltage drop. If there's a marina owner that's listening and you're experiencing voltage drop issues where motors sag or lights dim during busy seasons of 4th of July or Memorial Day or Labor Day or other events, and you're experiencing issues with outlets and plugs melting, it could be problems with the voltage drop, and you really need to check that out and resolve that issue to be able to resolve some of these fire hazards that's out there.
From a design standpoint, Gary, you hit it right on the head as far as it comes to wires being damaged. Voltage drop is by far the biggest cause of overheating and cabling equipment, and making sure that that's designed for early on in the process can eliminate a lot of these potential problems. Not on the electric shock drowning side, but definitely on the fires and damaged equipment side.
All right, gentlemen, thank you very much. I'd like to wrap this up with just, again, a couple of housekeeping items. One, this webinar, as well as part one, is available as a link through our website, abycinc.org, for the next 30 days at no charge to anyone who would like it. Feel free to send the link to people who have not watched it. If you need access to it after the 30 days, you can either join ABYC and get access to it and many other free webinars on the ABYC website as a member benefit, or you can purchase part 1 and 2 on a DVD. The notification will be emailed to you when it is available. Also, I would encourage you, if you do go to the IMBC show, please come visit us at our booth. Herman will be speaking on some of these issues as well, so his topic will be there also. ABYC has a free boating safety clinic coming up here in Annapolis on Saturday, August 25th. This is an event that we'd like to cast across the nation at some point, but it is qualified surveyors checking out boats for all different standards violations, not only electrical, but other CO issues and fuel issues and things as well. So if you are in the Annapolis area, please feel free to call us about that. Otherwise, again, thank you for being on these two webinars. I hope they are recorded. Chris and Gary, I can't thank you enough for donating your time to this webinar, and also for AMI for helping us sponsor this and get this off the ground. So with that, I will say goodbye to everyone on the phone. We appreciate it. We've had over 200 viewers here today, and I'm sure we will have over 700 or 800 reviews of this webcast, just like we did with Kevin Ritz's. So, gentlemen, thank you again. Appreciate it, and that concludes our presentation.